we want to find the limit as x approaches -1 of the given rational function. And we'll find this limit analytically and then verify it graphically. Notice if we tried to find this limit by performing direct substitution, the denominator would be 0, so we'd have division by 0, which is undefined. But this doesn't mean we can't find the limit by performing direct substitution. It does mean that we have to simplify this rational function, meaning if x plus 1 is a factor of the numerator, the factor of x plus 1 would simplify out, allowing us to find this limit by performing direct substitution. So the first step here is to determine if x plus 1 is a factor of the numerator. To do this, we want to divide x to the third plus 2x squared minus 4x minus 5 by the quantity x plus 1. If we perform this division and the remainder is 0, then x plus 1 is a factor of our degree 3 polynomial. And to perform this division, we can either use long division or synthetic division. Let's go ahead and review synthetic division. If we want to divide by x plus 1, we're going to use the constant -1 to perform the synthetic division, and then we'll list the coefficients of our dividend. So we'll have 1, 2, -4, -5. And now to start, we'll bring the first coefficient down, and then we'll start multiplying by our constant -1 and putting the product in the next column. So -1 times 1 is -1, and now we add each column. So 2 plus -1 is 1. -1 times 1 is -1. We add, it's -5. -1 times -5 is +5. We add, -5 plus 5 is 0, which is a good sign because that's our remainder, which means x plus 1 divides evenly into our degree 3 polynomial. And if we have a degree 3, we divide by a degree 1. The quotient is a degree 2 polynomial, so this represents 1x squared plus 1x minus 5, or just x squared plus x minus 5. So going back up to our limit, we can write this as the limit as x approaches -1, and the factored form of our numerator is going to be x squared plus x minus 5 times the quantity x plus 1, and our denominator is still the quantity x plus 1. Now that we have it in factored form, notice how we have a common factor between the numerator and denominator, which graphically represents a whole at x equals -1, which would not affect the limit. So we can simplify this out, leaving us with the limit as x approaches -1 of just x squared plus x minus 5. And now we can find this limit by performing direct substitution. We'd have -1 squared plus -1 minus 5. So we'd have +1 plus -1, that's 0 minus 5. So our limit is equal to -5. Let's also verify this graphically. So if we graph the original function, we would just have the parabola y equals x squared plus x minus 5 with a whole at x equals -1 because of this common factor. So here's the graph of our function. Notice as we approach x equals -1, which is here, from both the left side and the right side, we are approaching a function value of -5. I hope this example was helpful.